Hello. In this video I'm going to be going over the ground constraint features and workflow for the Spine Unity runtime. This video does assume that you already know generally how to use IK constraints in the Spine editor and how to export them, but will show a more advanced feature to leverage real-time terrain changes and things like that. So the first thing I'm going to do is select the Spine Raptor in the scene hierarchy and choose spawn hierarchy and choose follow route only. After adding skeleton utility, so you do need to have skeleton utility present. And on the root bone, I'm going to choose add child front foot goal, reselect the root bone again, and choose add child rear foot goal. These are the two constraints or represent the two IK goal constraints from the spine file. And if you change them to override mode, you can see that they control the IK joint the same way they would in spine. So by just overriding these, we can control these around, but if we hit the play button and let an animation play, it's going to look really weird. So this is generally not what override bones are used for. So I'm going to leave both the front and rear foot goals in follow mode and then apply the ground constraint to each of these, which will allow them to animate to their updated position but also keep themselves above the ground. So on the front foot goal, I'm going to click the add component button and type in ground, and there it is, skeleton utility ground constraint. It will show some useful scene gizmos. In this case, there's a straight line going up and down, and the parameters include a ground mask. Much like regular raycasting in Unity, this uses a mask to determine what objects to cast against. In this case, I'm just going to choose everything. And to see this in action, I'm going to create a cube, and we should be able to see the leg moves up and down. More of a ground-like object here. There we go. And to see that updating with the animation, it will still follow the bone, but will update after the position for the animation has occurred. You can also see a red line showing where the IK constraint wants to be based on the animation data. So it gives you a good debug readout of what's actually happening, or if you need to reanimate and make the IK goal lower if you want it to match the ground. So that's a start, but that doesn't look quite right. This foot has a very large flat bottom, and the constraint isn't really in the visual center of the foot. So there are other parameters in the ground constraint. I'm going to go through them one by one until we get something that looks good. First off, there's also the use 2D checkbox. Rather than using 3D raycasting, this uses 2D raycasting, but everything works the same after that. So I'm not going to go over that in this video. The use Radius checkbox changes the behavior of the ground constraint so that instead of raycasting against a single point, it raycasts against a radius. So I'm going to increase the radius so it's about as wide as the foot. There we go. And this has the effect of letting us push the foot up when any object comes within the radius of the cast. And again, it gives good debug features for what's being cast against and how far out we need to go, or if we need to adjust anything. The cast offset adjusts the cast to the left or right of the origin of the constraint. So I see now that my cast radius is actually a little too large after the offset has been adjusted, so I'm going to bring that back in a little bit. And the last parameter that's a little weird here is that the bottom of the foot is beneath the constraint graphically. So when I bring this object up, we're actually clipping on top of the graphics, and I don't want that. So I'm going to adjust the ground offset, or increase the ground offset so that the second white line here is visually beneath the object. So now when I move this up, we are now completely offset, and anytime something comes within range of the radius, then it will properly offset itself. So that's a pretty good setup for this particular foot. I'm going to right-click and do a copy component and paste all of these settings onto the rear foot as well by doing a paste component as new. It's not configured correctly, so I'm just going to quickly tweak the settings. Oops. I didn't want that. Where is it? Cast, offset, there we go. And we can probably dial the radius in for this one a little bit. With the ground offset, looks pretty good. There we go, all right. And hitting play, we can take a look at what that looks like now. Much better. Yeah, I'm pretty happy with that. So the last parameter on the ground constraint is the adjust speed. And what this does is changes how fast the ground constraint can move the IK goal up and down to match its desired position. You can't see this in action in the editor mode. It will just snap instantly because it makes more sense to see it that way, but at runtime when the animation is actually playing, you will be able to see it. So to show that in action, I'm going to shrink my ground object and take both the front and rear foot and change their adjust speed down to a very small value, let's say 0.5, and hit play. So when this foot comes down and we're no longer attached to the box, it's going to slowly move itself downward. You probably don't want it to move quite that slowly for visual reasons, but what it does do is it prevents it from snapping to the ground if there's no longer a collider or there's a very fast change in height between colliders or environment. So I'm going to increase the adjust speed to something like 50, and you can see the difference. So when this foot is no longer on top, it just snaps to the ground and looks very unnatural. I think even in a worst case scenario, we can watch the back foot do this again on both sides of the box and see why this is a very bad thing. Yeah, we don't want that. We want it to, if it does encounter that situation, you want it to be very smooth and subtle. So I'm going to change this back to a speed of, let's say 7. And we can see the difference. Yeah, that still looks pretty bad, but you kind of get the point. It does give you more control over how the foot behaves in a situation that may not be ideal for the IK ground constraint. Alright, that pretty much sums up this video. There is a pretty decent example in the examples scenes Raptor ground constraint sample. It doesn't cover ground radius, but that's okay. This video does. Alright, see you soon.